Problem 6-72. Find the equation in y equals ax squared plus bx plus c form of the parabola that passes through the points 1, 5, 3, 19, and negative 2, 29. All right, this is a great problem here because this is combining our last two lessons that we've learned in class. Remember, we've talked about how to solve systems of equations that have 3 equations and 3 unknowns. And then we're also going to be doing a little bit of curve fitting here because we're looking for this equation of this quadratic or this parabola here. We want to find out exactly what its equation is. So we're going to use these 3 points, the point 1, 5, 3, 19, and negative 2, 29 to help us create that system. So first of all, remember, we're using y equals ax squared plus bx plus c. Now each of these points is going to give us a little bit of information here that's going to allow us to create a little bit of more information in each of the equations so that we can solve them. So for instance, we're going to take each one of these and make a new equation. So the point 1, 5, I have the values x and y. So let's create our equation using 1 and 5. So I'm going to plug in 5. And you know what? Let's color code this so we can keep track of what's going on. So let's make this our blue one. We're going to plug in 5 for y. And that's going to equal a times 1 squared plus b times 1 again plus c. And we'll simplify that in a moment. Let's go ahead and create our other ones here. 319, this will be our red one. So our y value is 19. So we have 19 equals a times 3 squared plus b times 3 again plus c. And our last one, we'll go ahead and just do that in green. So put in our y again. We're going to say 29 equals a times negative 2 squared plus b times a negative 2 plus c. Well, let's simplify those now. I'm going to simplify the green one first since I already have my green pen out. Negative 2 squared is 4, and 4 times a is going to give us 4a. Negative 2 times b is going to give us negative 2b plus c should equal 29. Let's do our red one now. 3 squared is 9 times a gives us 9a. b times 3 gives us a positive 3b plus c equals 19. And then we'll do the blue one here. So 1 squared is 1 times a. It's just going to leave us with a. There's no need to write 1a on there. Plus b plus c equals 5. Now we have our system of equations that we can look to solve. Remember, the first step here is to take it, and we need to combine, 2 pairs of these 3 in order to eliminate a variable. So when I look at these, I see that c is the same in all 3 of them. The coefficient is 1. That makes it really easy to change. So I think that what I'm going to do is one of my pairs of equations I'm going to use will be the first 2. Let's number these. We'll make this equation 1, equation 2, and equation 3. That way you can keep track of what I'm talking about. So I'm going to combine 1 and 2 into an equation, and then I'm probably going to do 1 and 3 into an equation. Now, I'm going to try to eliminate c. So one thing I can do here right off the bat, since I'm using this with both of them, and I have 3 c's that are all the same, I'm going to go ahead and multiply this equation that I have times a negative 1 in order to make it easy for me to eliminate c with both of my other equations. So what I end up with here is negative a minus b minus c equals negative 5. So I'm going to use this one in place of this one when I set this up. So here we go. Let's do 1 and 2 first. Okay, so I'm going to do our two equations, 1 and 2. So I've got my negative a minus b minus c equals negative 5. And my equation 2, I've got 9a plus 3b plus c equals 19. So we're going to add these together. Our negative c and positive c will eliminate each other, giving us 0 there. So 9a plus negative a will be 8a. And negative b plus 3b is going to give me positive 2b. And then negative 5 plus 19 gives me 14. So I'm going to go ahead and just box that equation in there so I don't lose it. Remember, a big part of this is just trying to keep your work organized. So the second one, we've got, I believe we said we were going to do equation 1 and equation 3 now. So equation 1, remember I've already multiplied it by a negative 1 because I know that's going to help me eliminate my c's. So I've got here negative a minus b minus c equals negative 5. And my equation C, I have 4a minus 2b plus c is going to equal 29. So this will also already eliminate here. We're going to have our negative c and positive c gives us a value of 0. Combine our a's, we get 3a. Combine our b's, we get negative 3b. Be careful on that one. And then negative 5 and 29 gives us 24. Let's box this equation in so we don't lose it either, because now we have a system of equations, each with the same two variables. And now it comes time to decide, how do we want to solve this system here? You could do substitution, or you could do elimination. This one, if you're going to do substitution, this would be a great equation to, take your a and b, whichever one you want there, to isolate. You know what, I haven't solved it like that in any of these, so maybe I'll go ahead and do substitution this time. So I'm going to do substitution. I'm going to isolate my value of a in this equation here. So I'm going to do 3a minus 3b equals 24. So I'm going to add my 3b to each side. So right now I have 3a is equal to 24 plus 3b. And you see why I chose to do this one, because now when I divide by my 3 here, all of these numbers are divisible by 3, which makes it a equals 8 plus b. So if a equals 8 plus b, that's going to allow me here to take this expression, 8 plus b, and substitute it in for my a in my other equation. So let's take a look here. Let's take a and substitute the other value in. So we're going to have 8. Instead of times a, we're going to take it and we're going to multiply it by 8 plus b. And then we've got our plus 2b equals 14. So now we're going to be able to solve for b. So 8 times 8 is 64. 8 times b is 8b plus 2b equals 14. Looks like I might need a little bit more room here, so let's go ahead there and scroll down a little bit. Combine your like terms. You've got 64 plus 10b equals 14. Subtract 64 from each side. And we get 10b equals, looks like negative 50. Divide by 10 here on each side, and you get b equals negative 5. So we've solved for b. We've got that it is negative 5. Okay. Now that's going to be easy then for us to figure out what a is. We can use this expression right over here. A equals 8 plus b. So let's do that here. We'll do it right here. That'll work. Solve for a. So take that negative 5 and plug it in. We've got a equals 8 plus negative 5. 8 plus negative 5 is going to give us 3, so a is going to equal 3. Now that we've got a and b, let's take it here, and we need to go ahead and solve it for c. So let's look back up at one of our original equations that we've got here. We've got several to choose from there. You could do a plus b plus c equals 5. That looks like an easy one to work with, right? Let's do that. Why make it harder than it needs to be? So a plus b plus c equals 5. Let's take our two values of a and b. A is 3, b is negative 5. Let's substitute them in. So right here we're looking for c, just so you keep track of where I am, what I'm doing. 3 plus negative 5 plus c equals 5. So 3 plus negative 5 is going to be negative 2 plus c equals 5. We add 2 to each side, so we get c is going to equal 7. Now remember, we're not solving for an ordered pair here. We're doing curve fitting. We're trying to come up with the equation of our parabola. So if we've got a equals 3, b equals negative 5, and c equals 7, we're going to substitute them back into our equation. So we're going to say instead of y equals ax squared plus bx plus c, we're going to put our 3 in, we're going to put our negative 5 in, and we're going to put our 7 in. So the equation of that parabola should be y equals 3x squared minus 5x plus 7. So to check it, let's pull out that calculator here. Let's graph this equation, and then let's see if our original points end up being on there. So let's clear out whatever we have in there. We're going to go 3x squared minus 5x plus 7. Okay, we can graph it here, and you'll see, probably need to rezoom here. Let's do zoom 6. Oh, my bad. Let's do that again. Zoom 6. All right, so we can't see a whole lot of our parabola, but that's okay. We can see that our y-intercept is at about positive 7, so it looks like that's probably correct. Let's go ahead here. Let me move back up to the top of our page here. We said that our parabola is going to pass through 1, 5, 3, 19, and negative 2, 29. So let's look at our table. So at negative 2, you see that we are at 29. That works. Let's scroll down here a little bit. There's that point there if you're looking for it. For 1, we have an output of 5. That makes sense. And then if we get our 319, we're set. And you'll see right there we get it, 319. So, just to summarize one more time, you're going to take each point. You're going to plug it in for your x's and y's. Simplify it. So then you're going to use the 3 equations that you come up with as a system of equations to solve for those values of a, b, and c. Remember to take those values of a, b, and c, and then we're going to plug them into our standard form of our quadratic function. Again, our answer in this case, y equals 3x squared minus 5x plus 7. I'll write that up here. Now that was a good time. Problem 6-72.